In March of 2026, an interstellar object slipped past Jupiter at a distance so precisely, almost impossibly aligned with the boundary of the planet's own gravity, that one of Harvard's most respected astrophysicists publicly called it the most remarkable anomaly of the entire encounter. Scientists spent months calculating exactly what that number meant, running the physics again and again from different angles, and even now, not everyone agrees on the answer. The object in question is 3I Atlas, only the third confirmed interstellar visitor ever detected passing through our solar system, following 1I Oumuamua in 2017 and 2I Borisov in 2019. It was first spotted on J. Yuli 1st of 2025 by the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile, immediately standing out for its extreme hyperbolic trajectory, a path so fast it proved the object could only have originated from another star system entirely, arriving on a course so steep and so retrograde that it moves in nearly the opposite direction of every planet's orbit around the Sun. Discovered while still within the orbit of Jupiter, it was already moving at roughly 137,000 miles per hour, a speed that only increased as the Sun's gravity pulled it inward toward its closest approach in late October, eventually peaking at around 153,000 miles per hour at perihelion, before beginning its long, slow retreat back toward the outer solar system and beyond. After swinging around the Sun, 3I Atlas continued outward on the second leg of its journey, heading toward a rendezvous with the largest planet in our solar system. Using NASA's JPL Horizons calculation system and drawing on orbital data gathered from roughly 230 observatories around the world, scientists projected that the comet would reach its closest point to Jupiter, known as Perigove, on March 16th of 2026, passing at a distance of approximately 3.4 million kilometers, or roughly 0.358 astronomical units, a figure refined repeatedly over several months as more precise tracking data came in from telescopes across the globe. Here is where things got strange. Every planet in the solar system has what's known as a Hill radius, an invisible boundary marking the region where that planet's own gravity wins out over the much larger gravitational pull of the Sun. Calculate Jupiter's Hill radius for that exact date in March of 2026, using its distance from the Sun and the mass ratio between the two bodies, and you get a number remarkably close to 53.5 million kilometers. In other words, 3I Atlas didn't just pass near Jupiter. Its closest approach landed almost exactly on the very edge of the one region in space where Jupiter's gravity could actually capture. There's something moving that fast. A coincidence accurate to within a single standard deviation of measurement uncertainty. To put that precision in perspective, both Jupiter and 3I Atlas are moving through an enormous three-dimensional volume of space, and the fact that their paths intersected this particular invisible boundary rather than passing millions of kilometers to either side is the kind of numerical alignment that, at first glance, looks far too clean to be an accident. If precise cosmic coincidences like this fascinate you as much as they fascinate us, go ahead and like and subscribe, because what one scientist proposed next turned this flyby into a full-blown scientific debate. Harvard astrophysicist Avi Loeb, who has spent months cataloging unusual characteristics of 3I Atlas, seized on this alignment immediately, calling it the comet's most remarkable anomaly yet, and framing the timing as almost suspiciously convenient given everything else about the object's trajectory that had already caught his attention. His reasoning goes like this. Any object attempting to deliberately leave something behind in orbit around Jupiter, whether a natural fragment or, hypothetically, a piece of technology, would need to arrive somewhere inside that Hill radius in order for Jupiter's gravity to actually hold on to it rather than letting the Sun's gravity sweep it away. Land precisely at the boundary of that capture zone, Loeb argued. And you've engineered the exact conditions needed for a controlled release, provided whatever you're releasing also cancels out its own extreme velocity relative to Jupiter, something in the neighborhood of 66 kilometers per second. He described the scenario almost like a spacecraft executing a final parking maneuver at the last possible moment before a window closes, an image that quickly caught fire online and inspired exactly the kind of headline you've probably already seen. To be clear about what the actual physics requires, matching that scenario is far from simple. The escape velocity from Jupiter's gravity at the distance of its Hill radius is only about 2.2 kilometers per second, a tiny fraction of the blistering 66 kilometers per second at which 3I Atlas was moving relative to the planet. Any object attempting to actually get captured into orbit rather than simply flying straight through would need an extraordinarily precise and powerful braking maneuver, one that would have to happen at exactly the right moment in exactly the right direction, using propulsion far beyond anything humanity currently possesses. Loeb himself was careful to frame this as a hypothetical worth testing, rather than a confirmed conclusion, proposing that if the comet really had deposited devices near Jupiter, Astronomers might eventually spot new objects orbiting the planet that couldn't be explained by any known natural process. Discovery, he said, would represent a clear technological signature if it ever happened. To put the scenario in context, Loeb has maintained a personal ranking system for interstellar objects running from 0, meaning entirely natural, to 10, meaning confirmed alien technology posing a genuine threat. And even at the height of the Jupiter speculation, he placed 3I Atlas at only a 4 on that scale, reflecting genuine uncertainty rather than a firm conclusion in either direction. So scientists did exactly what good science demands. They went looking for evidence rather than simply speculating. NASA's Juno spacecraft, which had been orbiting Jupiter since 2016, studying the planet's composition, gravity, and magnetic field, was still active in the system at the time of the flyby. And researchers, including Loeb himself in a published feasibility study, explored whether Juno's remaining fuel could even be used to divert the spacecraft close enough to observe 3I Atlas directly during its passage, calculating that a carefully timed engine burn combined with a maneuver that uses Jupiter's own gravity to boost the spacecraft's speed could bring Juno close enough to study the comet with instruments no ground-based telescope could match. Separately, the European Space Agency's JUICE spacecraft, which happened to be in transit toward its own future mission at Jupiter, also turned its instruments toward the comet, beginning a dedicated observation campaign on November 2nd of 2025 that continued for over 3 weeks, with its closest approach occurring on November 4th at a distance of roughly 60 million kilometers. Because JUICE was still close to the Sun at the time, its team had to work around serious thermal constraints, using the spacecraft's own antenna as a heat shield and limiting observations to a handful of short windows, yet still managed to capture images using 5 separate scientific instruments, ultimately gathering more than 11 gigabits of data. The resulting pictures, released to the public in early 2026, revealed an almost egg-shaped nucleus wrapped in a bright glowing coma, with jets, rays, and filaments of gas and dust stretching out behind it. Some of the most detailed imagery ever captured of an interstellar object anywhere in its journey. Imagery that separate X-ray telescopes later complemented by detecting a faint diffuse glow around the nucleus, making 3I Atlas the very first interstellar comet ever observed in X-ray light. Neither Juno nor JUICE detected anything resembling a deployment event, a discrete propulsion signature, or any new object suddenly appearing in orbit around Jupiter that couldn't be explained by the planet's already well-documented population of moons and debris. Meanwhile, the broader scientific community continued gathering an enormous amount of independent evidence about what 3I Atlas actually is, and none of it points toward anything artificial. Spectroscopic data from the James Webb Space Telescope revealed extreme isotopic ratios of deuterium and carbon within the comet's water and gas, signatures consistent with an object that formed in an extraordinarily cold environment as long as 10 to 12 billion years ago, more than double the age of our own sun. Researchers also detected methane escaping from the comet for the first time ever, recorded on an interstellar object, with a methane-to-water ratio roughly 11 times higher than any previously measured comet, a striking clue about the frigid, distant environment where this object first took shape, long before our own sun ever ignited. A separate study, using the European Southern Observatory's Very Large Telescope, independently confirmed this same ancient natural origin story through analysis of the most direct tests possible. The SETI Institute and Breakthrough Listen Project conducted a dedicated radio search using the Allen Telescope Array, sifting through nearly 74 million individual signals collected while the comet was in range. Every single candidate signal that survived filtering was ultimately traced back to ordinary human and satellite interference here on Earth, ruling out any artificial transmitter from the object. Itself stronger than somewhere between 10 and 110 watts. Loeb has continued cataloging what he now describes as more than 20 distinct anomalies observed across the comet's entire journey. Everything from an unusual system of jets, producing a subtle non-gravitational acceleration in its trajectory, to a trajectory that carried it strikingly close to Venus, Mars, and now Jupiter in succession, a sequence he has called improbable enough to warrant serious scrutiny. Other scientists studying the exact same data have consistently pushed back, pointing out that with an object moving on a trajectory that intersects the orbital plane where all our planets happen to reside, some degree of close encounters with those planets becomes statistically expected rather than suspicious, and that jets, wobbles, and small trajectory shifts are commonly observed in comets that formed with an uneven distribution of ice across their surface. The overwhelming consensus among NASA, the European Space Agency, and the vast majority of professional astronomers remains that 3I Atlas is a completely natural ancient comet, its close encounters with the inner planets and Jupiter alike explained by ordinary orbital mechanics rather than deliberate design. Loeb himself has occasionally leaned into the philosophical side. of the debate as much as the technical side, remarking at one point that if 3I Atlas truly were an intelligently directed visitor, humanity's quiet, uneventful flyby with the object might simply mean we were not the point of the trip at all, joking that arriving late to a party in a room you're not the center of does not mean the party was ever about you to begin with. Where does that leave the Hill radius coincidence itself? Scientists who study orbital mechanics point out that hyperbolic interstellar objects passing through a planetary system will, by pure geometric chance, sometimes cross close to a Hill radius simply because that boundary sits at a specific, calculable distance from any given planet. And with enough objects and enough planets, some alignments like this are statistically bound to occur without anyone or anything engineering them. Critics of the artificial hypothesis have also pointed to the comet's earlier trajectory as evidence against deliberate design, noting that its path brought it unusually close to Venus and Mars as well, encounters that, taken individually, look dramatic in headlines but become far less surprising once you account for the fact that an object crossing the inner solar system along a path close to the ecliptic plane, the same flat disk where all the planets orbit, is statistically likely to pass near several of them purely by geometry. Whether this particular alignment near Jupiter was truly meaningful or simply an eye-catching coincidence remains, for now, a genuinely open question, one that will likely stay unresolved until the day, if it ever comes, that another interstellar visitor gives us a second data point to compare it against. What nobody disputes is this: 3I Atlas gave humanity its most detailed look, yet at a genuine relic from another star system, and whether or not its path near Jupiter meant anything at all, the sheer scale of the observation effort it inspired, from Webb to Juno to JUICE to a dozen other spacecraft racing to catch a glimpse before it vanished, was itself a remarkable achievement in modern astronomy. It also stands as a useful reminder of how science is supposed to handle a genuinely strange coincidence, not by dismissing it outright and not by treating it as automatic proof of something extraordinary, but by taking it seriously enough to test rigorously, gathering every scrap of available evidence, and then following that evidence wherever it actually leads, even when the more mundane explanation ultimately turns out to be the correct one. Scientists expect this kind of coordinated, all-hands response to become far more common in the years ahead, as next-generation survey telescopes like the Vera Rubin Observatory, which had already photographed 3I Atlas during its own commissioning phase before the object was even officially discovered, come fully online and begin detecting interstellar visitors on a far more regular basis, potentially transforming what was once a once-in-a-decade event into a routine occurrence for the astronomers, tasked with deciding, each time, whether the next unusual coincidence is worth taking seriously, and whether the next Hill radius alignment, a wobbling jet, or unexplained isotope ratio is finally the one that changes everything we think we know. By the middle of 2026, 3I Atlas had already faded to roughly 1 billion kilometers away, well beyond Jupiter, continuing its permanent departure back into interstellar space, unlikely to return to our solar system for hundreds of millions of years, if ever again. What it leaves behind is not proof of anything artificial, but an enormous, carefully documented dataset that scientists will spend years analyzing, and a case study in exactly how rigorous science is supposed to work. Propose a bold hypothesis, search hard for evidence either way, and let the data, not the headline, decide what actually happened at the edge of Jupiter's gravity that day in March.